In the second part of 1.6, we're going to continue learning about slope and average rate of change, but the main focus is going to be average rate of change. So we see this word average rate of change a lot within these couple of worksheets. And I'm going to go ahead and I'm going through and highlighting every single time that I see the word average rate of change, which should be in every single problem. All right, so this word's average rate of change, it's just a fancy way of saying slope. And we learned that the slope is the change in y divided by the change in x. So you're going to see throughout this activity, we're going to have different tables of information. And within each word problem, each table of information says to find the average rate of change. You're going to see two different things. You might see from t equals some number to t equals another number. So a and b are going to be numbers, or you could see it in interval notation for a comma b. Either way, all of this is just talking about the x values. All right, so we're talking about x values. So a and b are numbers, and you'll see as we go through it, we're going to be talking about time from one number to time being another number, or we'll see it in interval notation. So in number 1, we have hot water dripping through a coffee maker filling a large cup of coffee. The amount of coffee in a cup at time t, 0 less than or equal to t less than or equal to 6, is given by the function c of t, where t is measured in minutes. Selected values of c of t measured in ounces are given in the table below. Find the average rate of change of the liquid in the cup from t equals 3 to t equals 6. So there's my interval. We're going to start at t equals 3 all the way up until t equals 6. And we're going to include units as part of our answer. So just like when we first learned about this, y is in the bottom and x is on the top. We always do the change in y divided by the change in x. So we're only going to be focusing on the bottom first. Now, none of the other values in this table matter. We're only focusing on from x equals 3 until x equals 6, or in this case, time from 3 to 6. So I'm going to go ahead and count how many numbers are in 11.2 until 14.5, and I'm going up 3.3 numbers. So we have a positive 3.3 ounces divided by, next we have our change in x. So from 3 to 6, I'm going up 3 numbers. So we have positive 3 minutes. So there's my fraction. We're calculating the average rate of change, which is just a fancy way of saying slope. We're going to type 3.3 divided by 3 into our calculator to find 1.1, and then we just have to put units in our answer. So we have ounces per minute. We go ahead and do the same thing in number 2. So in this case, we have Joanna jogs along a straight path. For t is less than or equal to t less than or equal to 40, Joanna's velocity is given by the function v of t. Selected values of v of t, where t is measured in minutes and v of t is measured in meters per minute, are given in the table below. Find the average rate of change of Joanna's velocity from t equals 0 to t equals 20. Include units in our answer. So along my interval from 0 to 20, I went ahead and highlighted them. None of the other numbers matter. So if you notice, as the x increases, the y, it starts to increase and then it decreases again. We don't care about that. We only care about from 0 until 20. So again, we're going to do our change in y first. So from 0 to 240, I'm going up 240 numbers. And we have meters per minute divided by our change in x. So from 0 to 20, I'm going up 20. We have minutes. So in our calculators, we're going to reduce our fractions. We have 240 divided by 20, and we get 12. So we have 12 meters per minute over minute. So you can write it your line straight across, or in this one I put it almost like a backslash. Go ahead and try out number 3. In number 3, we're only focusing on the interval from 4 to 9. So I went ahead and highlighted them. My change in y is 4.7. My change in x is 5. And we get 0.94 degrees Fahrenheit per minute. In numbers 4, 5, and 6, we're talking about average rate of change, which again just means slope. So if you think back to the very first page of notes in activity 1, that m represented slope. Well, slope also means average rate of change. So we can do y2 minus y1 over x2 minus x1. Or in this case, since we have f of x equals 3x minus 6, this is written in slope-intercept form, where 3 is the slope, which means that 3 is going to be my answer for the average rate of change for each of my intervals. So these are given intervals. We have AB, 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 and I'll show you exactly what I'm talking about in number 8 with these intervals from A to B. In number 7, and once again, we're given this equation, h of t equals 0.5t plus 1, and we have this interval from 1 to 4. So those are x values from A to B. Again, this is written in slope-intercept form, so my average rate of change, or my slope, is 0.5. For numbers 4, 5, 6, and 7, we were given these equations in slope-intercept form. If you were not given the equation in slope-intercept form, we would have to use this rate of change up at the very top. So what we'd have to do is we'd have to do 0.5 times 4 plus 1, so we'd have this, minus, and then we do it again. So we have 0.5 times 1 plus 1, all divided by 4 minus 1. So we would be using that rate of change information in my bubble in order to find the correct answer. But either way, you would get this answer of 0.5. Finally, for numbers 8, 9, and 10, we're given my picture F. So my line F, these are given in interval notations from A to B. So I'm going to go ahead and put a little dot on 0. When x is 0, what's y? Y is at -2. So we have 0, -2. And then when x is 3, right here, y is 7. So we have another point, 3, 7. So I was able to get my y values given that x was 0. We go ahead and plot the point, and then x was 3 and plot the point, and we can figure out what y is. From here, we're going to do our change in y divided by our change in x. So my change in y, we're going up 9. So we have 9 in the numerator, divided by my change in x from 0 to 3. We're going up 3. This reduces to 3. Now, as long as it's a straight line, your other average rate of change will also be 3. But what you're doing is plotting points, figure out what your y's are, and then doing your change in y divided by your change in x. And this is how we do average rate of change. So we have successfully been able to calculate the slope of a line from a graph and also calculate the average rate of change from data.